I spent 100 hours learning astrophysics. Here's what shocked me most. After dedicating 100 hours to studying astrophysics through textbooks, lectures, and documentaries, I expected to gain a deeper understanding of space. What I didn't expect was to have my entire perception of reality fundamentally altered. Here are the revelations that left me staring at the ceiling at 3 a.m., grappling with the implications of what I'd learned. We are mostly nothing. The first shock came when I truly grasped atomic structure. If you enlarged a hydrogen atom so its nucleus was the size of a basketball, the electron would be orbiting about 2.5 miles away. Everything in between, empty space. This means that 99.6% of every atom is void. Your body, the chair you're sitting on, the device you're reading this on, it's all essentially empty space held together by electromagnetic forces. But here's what really bent my mind. This emptiness scales up to the cosmic level. If the sun were the size of a grain of sand in New York City, the nearest star, Proxima Centauri, would be another grain of sand in Los Angeles. The Milky Way galaxy, despite containing 400 billion stars, is mostly an incomprehensible vastness of nothing. We exist in isolated pockets of matter floating in an ocean of void so large that light itself takes years to cross between islands of substance. Time is not what we think. Einstein's special relativity isn't just theoretical. GPS satellites have to account for it daily. These satellites experience time dilation. Their clocks run faster than Earth-based clocks by about 38 microseconds per day due to weaker gravity at their altitude. Without correcting for this relativistic effect, GPS would accumulate errors of about 10 kilometers per day. But here's the truly shocking part. If you traveled to Sagittarius A, the supermassive black hole at our galaxy's center, and orbited near its event horizon for what felt like 1 hour to you, approximately 700 years would pass on Earth. This isn't science fiction, it's the actual warping of space-time by gravity. Time isn't a universal constant ticking the same everywhere. It's a flexible dimension that bends and stretches based on gravity and velocity. We're always looking at the past. When you look at the night sky, you're seeing a temporal map of the universe's history. The moon you see is 1.3 seconds in the past. The sun, 8 minutes and 20 seconds ago. When you observe Betelgeuse, you're seeing it as it was 640 years ago, around the time the Ming dynasty was rising in China. The Andromeda galaxy, barely visible to the naked eye, appears to us as it was 2.5 million years ago when early hominids were just beginning to use stone tools. The most distant galaxy ever observed, GNZ11, is seen as it was 13.4 billion years ago, only 400 million years after the Big Bang. We can never see the universe as it is now because now doesn't exist universally. Every observation is archaeological, every telescope a time machine. The universe is dominated by the unknown. Perhaps the most humbling revelation was learning that everything we can see, every star, planet, galaxy, and atom, makes up less than 5% of the universe. Dark matter, which we can't see but can detect through its gravitational effects, comprises about 27%. The remaining 68%? Dark energy, a mysterious force causing the universe's expansion to accelerate. We've mapped the cosmic web of dark matter through gravitational lensing, watching how it bends light from distant galaxies. Galaxies are embedded in vast halos of this invisible substance, like seeds in an invisible fruit. Without dark matter's gravitational scaffolding, galaxies couldn't have formed or would fly apart as they spin. We're cosmic minorities in our own universe, made of the rare exception rather than the rule. The universe is dying, very slowly. The concept of heat death initially seemed like distant science fiction until I understood the numbers. The universe is expanding and cooling, and entropy is increasing irreversibly. In about 10-14 years, star formation will cease. In 10-40 years, all protons may decay, leaving only black holes. Those black holes will evaporate via Hawking radiation over an incomprehensible 10-100 years. The universe is not cycling or renewing. It's on a one-way journey toward maximum entropy, a state where no more work can be extracted from any system. Every star that dies, every bit of heat that radiates into space, edges us closer to this cosmic finale. We exist in the universe's vibrant youth, a brief epoch of light and complexity between the Big Bang and the eternal dark. Quantum entanglement defies intuition. Perhaps nothing challenged my understanding of reality more than quantum entanglement. When particles become entangled, measuring one instantly affects the other, regardless of distance. This spooky action at a distance, as Einstein called it, has been verified repeatedly. Chinese scientists have demonstrated quantum entanglement between particles separated by 1/200 kilometers via satellite. This isn't information traveling faster than light. No usable information can be transmitted this way. Instead, it suggests that our universe's fundamental nature is non-local, that things we consider separate might be connected in ways that transcend our everyday understanding of space. The profound perspective shift. These 100 hours didn't just teach me facts about space. They fundamentally altered how I perceive existence. We're temporary patterns of matter and energy, mostly empty space, living on a mote of dust orbiting an average star, in a universe dominated by invisible forces we barely understand, looking always into the past, connected by quantum threads we can't fully grasp, in a cosmos slowly advancing toward its own heat death. Yet somehow this knowledge doesn't diminish us. It makes our existence more remarkable. We are the universe becoming conscious of itself, however briefly, against all odds.